In this video I want to show you how you can use strong asymmetric encryption on your Linux computer using GPG, which stands for GNU Privacy Guard. I will go through generating a key, I will go through encrypting a file, signing a file, importing keys, exporting keys, all that stuff. So yeah, let's just get into it. So I have two terminals here. On the left I have my normal user, Nick, and on the right I have this kind of example user, Kin. So these are just two users on my computer, but these, like, imagine these as two people. Like, imagine Nick as me and Kin as you or something. And I will first up start by generating a new key for this Kin user because he doesn't have any keys. So if we write GPG list keys, it will output that some directories were created. So this is if you first run GPG, you will get this output. But not much else because there are no keys. If we run this again, we get nothing. So how do we do this? Well, pretty simple with GPG quick generate key. And what this will do is generate a key with like some pretty good standards. And what you also have to specify is the user identity. So I will write, for example, this. I don't know, it doesn't matter in this case. Or let's just do it like that. And you can also specify, or you should specify, your email in these kind of anchor brackets. So for example, like this. And if you run that, it will ask you to, if you really want to generate a key for this identity. And if you press yes, alright, so input your password, whatever it is. Think of something good. It's best to use a key phrase. A key phrase like this, for example, 0. And a key phrase like this, for example, 0. And it should be, well, strong enough. So if you type in something trivial or something that's too short, this program will prompt you again for a passphrase. Alright, hit enter, and it will generate a new key. And it will output at that key. So the fingerprint of the key, the identity of the key, and also some more technical stuff with like subkeys and stuff like that, but that's a bit more complicated and don't want to go into that in this video. And also when the key expires. And don't worry about it. Like whenever like there's some expiry date, I tend to be like, oh, well, I don't want that because I don't want to have to think about it. But what you can do is you can change this expiry date at any point in time. And this is just so if you lose your key, if it gets compromised, it will, well, expire at some point in time. What you can do is you can do quick set expire, and then the fingerprint of the key. So the fingerprint is this right here. And then the date where you want it to expire. So we can, for example, choose this or something. Again, you can set whatever you want to. A key phrase like this, for example. If we now input GPG list keys again, we will see the key we have just created. And we will also see some output here. And we will also see that the expiry date has been set to 2040 November the 7th. Alright, so, and you can also set this to like some other date. Like it doesn't, you can set it arbitrarily is what I want to say. So don't worry about it. Alright, cool. So we have now generated a key. What I want to show you next is how you can export this key. So you can first up, for example, push it to other machines you have, or migrate it to other machines you have, but also to share your public key with someone else. So this is also super simple. It's GPG export armor and then the identity of the key. So either the fingerprint, yeah, we can do the fingerprint. And then if you hit enter, it will output it to standard out. But you can, of course, redirect that into, for example, kin.pub for public key. And if we now open that, we will see the PGP public key block. So this is your public key. And to export your private key, and you will need to export both the public and the private key to be able to import the key on another machine, for example, you can do export secret, what is it? Export secret keys it is. And we want to pipe it into kin pri. And it will prompt us for our passphrase again. key phrase like this, for example. Alright, and if we now open up this new file, it will show us our private key. So yeah, and I mean I will delete this key afterwards, so it's fine for me to show this here, but of course you want to keep this, well, private, obviously. Alright, what I want to show you next is how to import a key, because, well, that's important. And I will kind of show you a real-life example where I import my own key from my website. So I have my key at my website at no.pub, and if we call that, it will output the public key, so my public key. And we can now again redirect it to a file. And if I open it up, it's this again. So, and if we now want to import this, so put it into our key ring, because if we again list keys, we will only see our key, but we want to have the key of someone else here as well, so we can encrypt files for them or check signatures. We can simply write GPG import and then the key. And if we do that, it will import the key. And if we list keys again, we will now see two keys, the one we have created and the one we have just imported. Alright, next up, we need to trust this key, because right as it is now, if we try to verify a signature or encrypt a file for someone else whose key we have just imported, it will give us a warning and stuff like that. So it's good practice to kind of trust your keys. And trust in this case only means, okay, I'm sure that this key belongs to this person. So that this key, the key with this fingerprint, belongs to the person with this identity. So it's really not that, yeah, trust is kind of a strong word, I guess. So how you do this is you have to edit the key. So you type GPG -- edit key and then the fingerprint of the key. And now we can do lots of stuff here. We can also set expiry and whatnot. But we want to type in trust, and it will ask us how much we trust the person, or trust that this key belongs to this person. And we are very sure because we got the key, for example, from the website or something like that, or they send it to us per mail or whatever, or via mail or via email. So we type in 5, yes, ultimate trust, blah blah, okay, yeah. And then we can hit Control D to exit the GPG program. Alright, so now for something practical, finally, we want to encrypt some data. So first of all, we need some data, so let's just create a file. For example, we want to have hello there in a file, which we want to then encrypt and send to our recipient. So let's just echo that into a file.txt. If we get that, of course, hello there. And now we can list our keys again, and we want to encrypt this file to send it to the recipient or the person who has this key. So we will use this key, this fingerprint, and encrypt the file by typing GPG and encrypt recipient, if I can type, then the fingerprint. And I think you can also type the email or the identity, but the fingerprint is always the most obvious, or the safest choice, because it's unique. And then we want to type the file, and what happened is a new file was created, which is called file.txt.gpg, and this is now just some, if we open it up, it's just scrambled data, because it's, well, encrypted. Alright, so if we now, let's just move this file to the temp directory, so my other user has access to it. And if we now type GPG decrypt, because remember, so this Nick user has the secret key to this private key, which we imported. And if we type decrypt and then temp and file.txt.gpg, it will prompt me for my passphrase. And after I've input that, it will output the contents of the file. So hello there. And don't worry about that there was a graphical window now, and before that was the terminal window which asked for the passphrase. You can configure that on your machine. So yeah, that's how you encrypt and decrypt files. And this is also what's used in email encryption, for example. So it's really quite simple. And we can do the opposite now. So for example, let's just, so we have our public key here, and if we copy this public key to the temp directory, and now GPG import temp kin top, we can now encrypt a file or encrypt data for this kin user. So the opposite direction. And yeah, the way you do this is again GPG encrypt and then recipient, and then the ID, for example. So this is only a partial fingerprint, but yeah, and then the file you want to encrypt. So it's pretty straightforward. All right, next up we want to sign data. Oh, one thing I forgot when I talked about trust was what you often see on websites is fingerprints. So how you get these fingerprints is by running GPG fingerprint, and it will output these fingerprints in like the normal format that's often used, so in like blocks of 4. Yeah, so that's a bit more readable than just running list keys, which will output this, which is kind of not that readable. All right, that's just something I forgot to mention. All right, next up, signing data. So encrypting data is for, well, encryption. So you want to encrypt a message for someone else. With signing data, or by signing some data, you want to let someone else make or you want to verify to the public that some data is from you, or that you have, well, signed it. And so this is again pretty straightforward. Let's create a new file. For example, hello, this is me. Pipe it to sign, for example. So we have this to sign file. And what we can now do is GPG sign, and then this to sign file. And what it will create is again a toSign.txt.gpg. And if we now cat that, it's again scrambled data, because it's a cryptographic signature. And what we can now do is we can type GPG verify. If we now specify this where the signature, it will try to verify the file to sign.txt. And of course it says the signature, when the signature was made, and well, good signature. So this is pretty, I mean, this is a toy example, of course, because, I mean, yeah, of course it's from us. I mean, we just issued the command to sign it. But if we copy these two files again to our temp directory, and now go there and run GPG verify toSign.gpg, it will issue the following. So again, we see these 3 lines. Okay, when the signature was made, by which key, and if the signature is good, so if it's actually from the person we think it is from. But then it will also say this key is not certified with a trusted signature. There's no indication, blah blah. And then also the primary key fingerprint. So this is what I was talking about earlier, about having to trust your keys, or having to trust the keys you import. So we can now issue edit key, and then with this signature, with this fingerprint, I mean, and then if we type trust and type 5, yes, full trust, and now exit the program by Control D, we can now verify that again. And this time it says good signature without giving us any warnings. It gives us some additional output here, but it doesn't give us any warnings. So yeah, that's how you sign and verify signatures. And again, this is pretty important for like, yeah, for like messages, which you want to make sure, which you want to make sure came from a particular person or organization and stuff like that. So this is, for example, also what's used for well, pretty much any package manager. So whatever you use, and maybe you've come across that by if you used like apt in Ubuntu or something, that there was some, well, a missing public key or whatever, or missing signature or can't verify signature, and you had to like import that with GPG by using some key server. And key servers are another thing which I don't want to go into this video but yeah, so that's signing data. And last up, I want to show you how you can delete your key. So let's clean that. So we will delete the key we have created. So this one right here. So we will delete this and then, yeah, maybe import it again. How we do this is by typing delete keys and then, for example, your email, or again the fingerprint, if I can spell. And it will give us an error because we have a secret key for this public key, and we first need to delete the secret key. So how we do this is pretty straightforward. It tells you right here, delete secret keys, and we want to delete this. Yes, 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 yes. Okay, so now the private key is deleted. And we can now delete the public key as well. Alright, see ya. So now it's gone. If we list our keys again, we now only see the one key we imported earlier. And what we can now do is import the keys again. So, for example, first the public key, and then the private key. And for the private key, it will ask you for your passphrase. A key phrase like this, for example. Alright. And now if we run GPG list keys again, we have our key again. So, and we can do all the stuff I've showed you earlier. So encrypt files, sign files, and so on and so forth. Alright. So, and you can use this also with email programs. So most email programs have support for PGP. So, because I want to kind of make a remark if you come across that. So, GPG, so the program we've just looked at, the GNU Privacy Guard, implements OpenPGP. So, OpenPGP is just a standard. Like, for example, HTTP is a standard, or HTML is a standard. So, it's a standard, and it stands for pretty good privacy. So, if you come across OpenPGP or OpenPGP, PGP, or something like that, or not something like that, but if you come across these two terms and wonder how they relate to GPG, which is the program we just looked at, GPG is a free software implementation of this standard. I hope that's clear. Alright, and I didn't want to say that in the beginning because that's kind of dry, boring stuff. So I think it's more important to be able to actually use this stuff instead of knowing like details like that. But if you come across that, don't be confused. Alright, so I think that's pretty much it. We've looked at, I think, all the relevant stuff to actually use asymmetric encryption. So yeah. Oh yeah, and also small remark on this. So why asymmetric? Because you encrypt a file by using the public key, and you can only decrypt it by using the private keys. You have two different keys. Symmetric encryption would be you encrypt a file with a password and you can decrypt it with the same password, if that makes sense. So, for example, AES is the advanced encryption standard is a symmetric encryption, while again GPG is asymmetric. But yeah, so if you care about encryption, just look it up on the internet and you will quickly learn about the different forms. All right, so there was quite a bit of stuff. I hope you learned something. I hope you can now use GPG and sign and encrypt messages. And yeah, I think that's pretty much about it. That's all I wanted to say in this video. And yeah, have a nice day.